This related rates problem is about circles. We have a stone that's dropped into a calm body of water. So think about like a lake or a pool or something like that. And when you drop a stone into some water, you get ripples. So those are circles that start out very, very small and then gradually get bigger and bigger and bigger. So it kind of looks like a target. Um, Concentric means that you have one circle that is completely inside the other circle, um, and the distance between the circles is the same all the way around. So you know. The radius of the outer ripple, so that's the ripple that starts out at the beginning, and then that ripple grows and gets bigger and bigger and bigger. That outer ripple is increasing at a rate of 1 foot per second, its radius is. Okay, when the radius is 4 feet, at what rate is the total area of the disturbed water changing? So we're looking for the rate of area. How fast is area changing? All right, here we go. So identify all the variables involved in the problem. If we're talking about area of a circle, we need area and we need a radius. Area is usually a capital A and then radius is a lowercase r. Okay, if you think about a small circle and a big circle, the radius has changed, as has the area of a small circle versus a large circle. So neither of those variables is constant. Okay, let's identify the rates that are given and the rate that we wish to find. So we need dA dt, which is how fast the area is changing. We are asked to find what rate is the area changing. So we don't know. Let's figure out a label for it right now though. So dA, A area is in some units squared, and T for time, so that's going to be something squared per, let's see, time is in seconds. And the radius has feet as its label, so the area is going to be feet squared. Radius, dr dt is the rate that the radius is changing, and we are told that that rate is 1 foot per second, so dr dt, 1 foot per second. Okay, let's write an equation. What equation is for area of a circle? Area of a circle is A equals pi r squared. Okay, next one. If we have a variable that is constant, we would substitute it in now. Area was not constant, radius was not constant, so we cannot do anything else. Okay, number 5. Implicitly differentiate both sides with respect to time. So that's going to be dA dt equals, bring the 2 down, so 2 pi r times chain rule dr dt. We need an instantaneous rate or value. So all of this happens at the instant when r equals 4 feet. Labels on everything. All right, so dA dt is what we're looking for. That was our question mark. So we don't know. dA dt equals 2 times pi times the radius. The radius is 4 feet times dr dt is 1. Okay, now based on what I did on the last problem, let's double check. Is anything supposed to be negative? Well, the radius was increasing, so that rate should be positive. You can't have a negative radius, so that can't be negative. And the circles are getting bigger, so your rate for your area to change should be positive as well. All right, let's multiply this out. dA dt equals 8 pi, and our label that we found up above was feet squared per minute. I've mentioned before that dA dt is not a fraction, but we can kind of think about it as a fraction. I know it's a little bit messed up, but the A on the top is feet squared and the T on the bottom is minutes. So that helps you with your labels. except it's not minutes, it's seconds. Because that's what the rate of the radius was changing for. All right, sentence at the end. At the instant, when r equals 4 feet, the area of disturbed water is, it's positive, so it's increasing. The area is increasing at a rate of 8 pi feet squared per second. Period.